Hello there. So today you guys are going to be doing some more conversions, but the thing that we're going to be doing differently than Thursday is we're going to be adding sometimes more than just one step in our conversion, but we might be doing 2 or 3 steps. We're going to still use the dimensional analysis structure, which is going to really help us organize and keep track of our units. So let's do this first one together. We've got a substance right here, which is called silver nitrate. And silver nitrate has been given to us in its mass. So we have 54 grams. Okay, so we need to figure out the molar mass in order to convert from the mass in grams into moles and then molecules or atoms, because this is our given quantity right here. So we're going to try to convert, but we need a conversion factor first, and we're always going to need to get the molar mass for that conversion factor. So let's do that over here. So MM is the abbreviation for molar mass, and we've got the chemical equation is Ag for silver, NO3. So let's break it up. Ag is got a molar mass of 107.87. I'm gonna stop right there. And we've got one of those, okay? So I'm just gonna say there's one, and then we've got nitrogen. Nitrogen's got a mass of 14. There's only one nitrogen, and then we have oxygen. Oxygen's got a mass of 16, and there are 3. Okay, so that's 48. Okay, so I've got a total molar mass here. 14, 15, 16, 17, 18, 19. Some quick math here. 6 and 1. 169.87 grams per mole is going to be my molar mass, which goes right here. Okay, now I need to convert from these grams right here, my given, which is 54 grams of silver nitrate, into moles. So I'm going to start with my given on the left. That's 54 grams of AgNO3. Set up my dimensional analysis, so times line, and I want moles. So I'm going to put the mole on top. I'm going to write 1 mole of AgNO3 is 169.87 grams. Okay, so that's going to get me the moles that I need. I'm going to go ahead and cancel the grams. I'm going to multiply the numbers on top, and I'm going to divide the numbers on the bottom. So when I do that, I have 54 times 1 is just 54, divided by 169.87, and I get equal to 3.18 times 10 to the negative 1 mole. And if you didn't do that in scientific notation, that's okay. If you wrote down 0.318 mole, that's also fine. Take a look. our given has 1, 2 significant figures. So that's how I'm going to round and get my answer. I'm going to round based on that. So there's 2 significant figures. So this is going to become 0.32 moles. Okay, or in scientific notation, that would become 3.2 times 10 to the negative 1 mole. All right, so you're going to go ahead and box up your answers, and that's going to go into this box right here. So 0.32 moles. Okay, the next thing that I'm looking for is the number of molecules. So I can set up another dimensional analysis to do that. So now that I have the mole, I can convert into number of molecules or atoms. So here's 0.32 moles, and that is of silver nitrate. Don't forget to write your substance. It's always important next to your given, times line, and I'm converting into an object, which is a molecule or an atom, which means I'm going to be using Avogadro's number. So I have the mole, so 1 mole is equal to 6.022 times 10 to the 23rd molecules or atoms. Doesn't really matter. Molecules or atoms. Okay, now I can cancel out the mole. I'm going to multiply the number 0.32 times 6.022 times 10 to the 23rd, and that's going to give me 1.9 times 10 to the 23rd molecules. Or atoms. Okay, so this is going to be what I write over here. I can put atoms to be short, or molecules. Okay, so what you can see is we had to do 2-dimensional analysis in order to do that. We did it in kind of 2 different stages. We could also be a little quicker if we just make a line with our dimensional analysis. We make a straight line. So let me show you how we can do that. Let's actually go back.